Good morning, this is Kasturi Day. Today I am going to discuss this chapter, the physics chapter, matter, according to ICSE syllabus class 8. Uh, so today I'll start with the states of matter. Okay, before starting, yesterday I concluded at the assumptions that are made regarding the molecules of any kind of matter. Okay, so now I'm starting with the states of matter. There are three states of matter, three physical states of matter: solid, liquid, and gas. Okay, the solid is, example is steel, liquid example oil or water, gas example air. Okay, the state of a substance that can be changed by changing its physical condition like temperature uh, is the state of matter. Okay, the state of a substance that can be changed by changing its physical condition like the temperature, that is known as change of state of matter. Now, for example, water can exist in all the three states, like ice, which is a solid state, then water, that's a liquid state, and then the steam, that is the gaseous state. Okay, now the solids which are rigid, they have a definite size or and shape, definite size or volume you can say, and this shape, definite shape. They have a strong intermolecular force, they have less kinetic energy, that is the molecules have less kinetic energy, they do not randomly move. Okay, uh, they have reduced intermolecular space, where that is the molecules lie very close to each other. Then the liquid, they are not so rigid like the solid, they have a definite volume but no definite shape, that's why they take the shape of the container. Then they are not so much strong intermediate, they do not have so much strong intermediate for intermolecular force. Okay, they have sufficient kinetic energy so that the molecules have sufficient kinetic energy so that they can move to and fro. Okay, then they have increased intermolecular space. Okay, more than the solid, their intermolecular space is more than the solid. Then the gas, we come to gas. The gas are not rigid. Okay, they do not have a fixed volume, a definite volume, and neither a definite shape, so they always acquire the volume and the shape of the container in which they are kept. Their intermolecular force is very less. Okay, and so they can move here and there, and their intermolecular spaces are also very less. I mean, very it's too much of intermolecular spaces are there, so that they can move uh, through a long distance, they can travel between a long distance. Okay, next we come to the arrangement of the molecules in a solid or a molecular model of solids. Okay, for example, iron weight. Okay, see the picture, there's a black color, that is the iron weight. In this, in the solids, the molecules are very tightly packed as the molecular spaces are very small, so the molecules attract one another with a strong force, that is the intermolecular forces are more. The intermolecular force of attraction holds the molecules at a particular space. Okay, and that's why they have a definite shape. Then, because of the fixed position of the molecules, the solid have a definite shape and the definite volume. As the molecules attract each other with a very strong force, so it is difficult to tear them apart. So solids are rigid and hard. Okay. Then we come to the arrangement of the molecules in a liquid of molecular model of liquids. Okay. See, for example, water. In liquids, the molecules are less tightly packed, and so their intermolecular spaces are large and their intermolecular force is less as compared to the solids. So, due to the lesser force of attraction, the molecules do not stay at one place but interchange their position. as the position of the molecules easily changes, so they take the shape of the container. And however, as the number of molecules in a given liquid remains the same, say do they have a definite volume. Okay. Next, we come to the arrangement of the molecules in a gas, or you can say molecular model of a gas. For example, air. Okay, in gases, the molecules are so much far apart that they hardly attract each other. Okay, that is, their intermolecular force is very less and intermolecular space is too large. That's why they are far apart. Okay, the molecules move independently, and so gases have neither definite shape nor definite volume. They can fill in the entire space in which they are enclosed. That's why if we place a drop of perfume in a closed room, we will see that whole room becomes fragrant with that perfume in few minutes. Okay, so why there are two questions which I'll ask in this video. Okay, so first one is, why are liquids and gases flow? Why can liquids and gases flow? And why can adhesives join substances? So these two questions, you please give the answer right in the comment box. Okay, I'll discuss it in my next video. Okay, so next we come to the surface tension. This surface tension is a phenomena due to which exposed, that is the top surface of a liquid contained in a vessel, behaves like a stretched membrane. Okay, the top surface of a liquid that behaves like a stretched membrane. So this phenomena is known as surface tension. This phenomenon is mainly caused due to the unbalanced cohesive force acting near the top of the liquid, as explained under. I'll explain it now. Okay. For example, an isolated small cube of mercury in space. In a place, if we keep an isolated cube of mercury, what will happen to it? We will see that it will start circling. It will start forming balls. Okay, why this happens? Or if we place a pin on a totally filled glass of water, if we just place a pin slightly, we'll see it will float on that surface. It will not drop down. Why is it so? So, see, a molecule of mercury at A shall be pulled by the neighboring molecules equally. Okay, neighboring molecules of mercury will pull that molecule A of mercury towards itself. So, an unbalanced attractive force will act on it, moving and move it in some particular direction. In one direction, it will move. See, in the picture, you can see the molecules will attract it. In such a way that will start moving in one direction and it will take a shape of a ball. Okay, similarly, most of the molecules of the mercury within its main mass will not experience any unbalanced force. The other part of the mercury which is placed, which is away from that one drop, will not experience such amount of force. Okay, so it will remain like that. The other part which is experiencing that force, unbalanced force, will come closer. It will pull from one side. Okay, now however, the molecules near the edges will be pulled inward because of the unbalanced force of cohesion acting on them. But these molecules will not move inward as their movement is opposed by the inner molecules. Okay, it will not move inward because the inner molecular force is opposing that motion. This results in tension in the surface. Molecules of these redesign themselves in such a way that no unbalanced force acts on them and forms a spherical shape. Okay, so that no unbalanced force act on them and it forms a spherical shape. Due to this reason, when a small drop of mercury is poured on a glass top, it takes the shape of a spherical ball. But When a small drop of water is poured on a glass top, it takes an oval shape because the coercive force between the water molecules is less than the adhesive force between the water molecules and the glass top. See, coercive force is a force which is force of attraction which is between the similar molecules, and adhesive force or addition, force of addition, is the force between the different molecules, molecules of different particles. Okay, so like the force of between the water molecules, different molecules of water, that is coercive force, and the molecules of the different molecules, that is the molecules of water and the glass, that is of uh, adhesive force. Okay, so the coercive force is less than the adhesive force, then that's why in case of water it will not form a circle, not form a round. But in case of mercury, this coercive force is more than the adhesive force, that's why it forms a spherical shape. Okay, so I'll stop here. I'll continue with the rest of the video in my next rest of the chapter in my next video. Please go through this, and please write an answer to the questions which I've asked in my video in the comment box. Okay, if you like the video, press the like button, share with your friends, okay, so that they can also be benefited from this. And if you are a new viewer to my channel or not subscribed yet, please do subscribe to get the notification of my next video. Thank you.